Good morning, students. Now, today's lecture is a human reproductive system. It is a new chapter, and this one is the third chapter of the plus 2 classes. As you know, that the human is unisexual, means separate sex, and it is sexually dimorphic. It means the male and female can be diagnosed morphologically separately. Morphologically, there is no any problem to diagnose that. It is called sexually dimorphic. Now, the sex organ, on the basis of the certain studies, we can divide sex organ into primary sex organ and secondary or accessory sex organ. Primary sex organ, that particular sex organ, those are responsible to release or form gametes and also release hormones. Say for example, male testis and testosterone is hormone released from the testis. So it is primary sex organ, male testis, testosterone, and primary sex organ because they are responsible for the formation of the sperm. It is the male gamete also. In the case of female, ovary is the primary sex organ, and it releases about 3 or 4 types of the hormones, that is progesterone, estrogen, etc., and also responsible to release ova. So it is also primary sex organ. But in addition of that, there are so many other sex organs. Those are responsible for the providing assistance to that particular sex organ in sexual activity as well as the reproduction of the kids or like that. Just like we will discuss the firstly male sex organ or male reproductive system. Male reproductive system. Firstly, we will study the primary sex organ. It is testis. It is testis. Now, we know that their number is 1 pair, and before birth it is present in the abdominal cavity. Before birth of the baby, it is present in the abdominal cavity. But just either after birth or just before birth, it is shifted to the scrotum. And through inguinal canal. Now, after shifting that both the testes remains scrotum till death. Their number is 2. Suppose this one is the scrotum and is present 2 oval structure. It is called septa, and this one is the testis. This is the inguinal canal. This is the inguinal canal. It has been observed that a cord-like structure will come from the abdominal cavity. Cord-like structure comes from the abdominal cavity. And it contains vasa differentia, it contains vasa differentia, arteries, veins, lymphatic vessels, etc. It is attached with the outer margin, which give the proper position of the testis inside the scrotum, and that is called gubernacudum. Now the question that why this particular testis sits inside the scrotum? Why not testis present inside the body cavity? The answer is that it is a site of spermatogenesis. This one is the site of spermatogenesis, and spermatogenesis have need of the temperature below 2 to 2.5 degrees Celsius, lesser than normal body temperature. Because of that, it is shifted in the scrotum. The outer covering is highly pigmented and very thin. It is called Dotto's muscle. Dotto's muscle. And it is also responsible, it is mainly responsible, not also but mainly responsible for the maintaining the lower temperature. Now, we will have to study the internal structure of this particular testis. But before internal structure, we will draw a typical structure of the. It has been observed that this type of structure has been observed in a testis. If it is testis, that is epididymis. Actually, its location is not the lateral side, but its location is just opposite to it. But for sake of the study point of view, we have just seen epididymis, and this epididymis open into the high tubular coiled vasa differentia which insert inside the inguinal canal. And one thing, that whenever the both testes shift into the scrotum through inguinal canal, the inguinal canal gradually shrink, and a time will come that they are so small that they can't permit this particular testis to go inside it, or the other viscera to come inside it. If due to the certain cause, certain disease, a viscera will come here, then it is called inguinal hernia. Otherwise, in normal condition, nothing can pass through it. Only this particular cord, that is called, that is the vasa differentia, or the vessels or the arteries, or this will come from this one. Now, we'll have to study the PS of this particular testis. TS of the testis. We can observe that there is an outer covering of the testis, outer covering of the testis. It is somewhat thick. And it is called tunica vaginalis. Tunica vaginalis. The second part is called, their location is like this. Like this. And this is called tunica albuginea. Tunica albuginea. This type of infolding is called testicular septa, and this is called testicular lobule, and their number is 200 to 300 in a normal testis. Below this particular tunica albuginea, there is also a layer that is called tunica vasculosa, and actually it provides nourishment to this particular part. That is called tunica vasculosa. Now it has been observed that each and every testicular lobule have this type of coiled structure, this type of tubular structure. Their number is 1 to 3. It may be 1, 2 or 3. This type of structure. And here it is somewhat straight. Somewhat straight. It means the maximum number of this particular tubular structure, that is called seminiferous tubules. That is called seminiferous tubules. Their number is maximum 900. But it may, that is the maximum, it may change, because here the number of lobules is 200 to 300 and their number is 1 to 3. So it may vary, but here the maximum number will be 900. Now what happens? It make a network. It is called rate testis. It is called rate testis. And it is called vasa efferentia, which ultimately combine to form tubular structures, many more tubular structures which open inside it. A tubular, highly coiled tubular structure, because it is the site to retain the sperms for many more times. And this is called epididymis. Epididymis. And this is the capute part. And this is the cord part. And ultimately it has been observed this tubular structure will insert inside the body cavity through inguinal canal. Now, if you cut, this is the LS of the testis. There are so many, this type of the seminiferous tubules are observed, and that is the actual site of the spermatogenesis. Now, if you cut a section of this part, then what happens? Now we will have to study the transverse section of the seminiferous tubules and the internal structure of this particular seminiferous tubules. We know that the number of seminiferous tubules are maximum 900 in one testis. We have discussed in previous lecture why it is 900 maximum number. Here in this particular section you will see that if a testicular lobule have 3 seminiferous tubules, then 3 circular structure will be observed in a transverse section. We will have to study a single structure. Just you will observe that 2 types of the cells are present here. One, the shape of this particular is somewhat oval, and shape of this one is the elongated. This oval shaped structure is called germinal epithelium, and they are responsible to produce the sperm by meiosis. This germinal epithelium by meiosis produce sperm. By the process of spermatogenesis, we will discuss it later on. This sperm, whenever convert into spermatocyte, this germinal epithelium convert into spermatocyte, then this spermatocyte is attached with the Sertoli cell. It is also called sustentacular cell, and they provide nourishment to this particular juvenile sperm and provide maturation. So it is also called nurse cell. And after maturation, this sperm move to the epididymis, and there they stored and matured. Now, in addition to these two cells, that is the germinal epithelium and Sertoli cells, these three seminiferous tubules are attached together by the connective tissue, and this is the connective tissue. Connective tissue, and in the center of the connective tissue, the certain leading cells are present. It is also called interstitial cell. Interstitial cell, and they are responsible to release the testosterone. Just you know that the LH and FSH is the very much important hormones of the female reproductive system. Here FSH is also been released, and the action of the FSH is to start the spermatogenesis. But LH, that is called luteinizing hormone, is renamed or the named in this particular male reproductive system as interstitial cell stimulating hormone, ICSH. ICSH, because it acts upon this particular Leydig cell or interstitial cell to release the. We will have to study the accessory organs of the male reproductive system. Yeah, in human reproductive system, here we will have to study that the accessory sex organs, their function, and in addition to that, primary sex organ. You know that the primary sex organ is this one, that is called testis, and we have discussed detailed discussion in the previous classes. Now here we will observe that the seminiferous tubules is the site of spermatogenesis. It means accessory organs are number 1, epididymis, that is called vasa differentia, ejaculatory duct, penis, urinogenital tract, and seminal vesicles, bulbourethral gland, and prostate gland are also the accessory organs for the male reproductive system. Here we will have to discuss the functions of these particular accessory glands, accessory parts of the male reproductive system. Firstly, epididymis. It is the storehouse of the sperm. After spermatogenesis, these sperms come inside the epididymis and there they store, and that particular sperms will eject out through vasa differentia into the body cavity. It moves above the urinary bladder. It is called urinary bladder, and joined with the urinary tract. So it is called urinogenital tract because it is responsible to carry urine as well as the product of the testis. So it is called urinogenital tract. Before opening of ejaculatory duct, before opening of this particular vasa differentia into the urinary tract, it join, and that joint point is called ejaculatory duct, and it has three glands. One is called seminal vesicle, another is called bulboutral gland, and third one is called prostate gland. As you know that the pH of the urine is acidic, and if sperm will come in contact with the acidic pH, then what happens? It will die. Because of that, it is very much essential that this tract, because this urinogenital tract is common for the urine as well as this sperm or the semen. So it is very much essential that it should be neutralized. And for neutralization, the seminiferous tubules and the bulboutral gland and the prostate gland, whose secretions are alkaline, is very much essential. Secondly, sperm, the number of sperm is very high, but the quantity is very low. When sperm is just going to eject out, before that particular ejection, the certain viscous liquid which is alkaline in nature from the seminiferous tubules, bulboutral gland and prostate gland will be released and make that sperm into the semen. So this is the main two function, as well as this particular tract should be lubricated by the secretions of the seminiferous tubules, bulboutral gland and the prostate gland. Here at the end of the penis, that is the glans penis, it is highly vascular part of the penis, and it helps in the erection, as well as they are responsible for the providing the nutrition at the time of ejaculation of that particular semen. So this is all about the accessory gland, accessory part of the male reproductive system. We will discuss about the female reproductive system.